Hello everyone. This year in grade 3 we will start our first chapter about pattern and graph, lessons from 1 to 10. Our main topics in this chapter are pattern, graph, measurement. We will start with pattern. We have three types of pattern: visual pattern, number pattern, dot pattern. We will start with the first one, which is visual pattern. From its name, visual, it means it uses colored images or elements arranged based on a rule. Here we have an example: star, heart, star, star, heart, heart. What did you notice? We have here star, heart, star, star, heart, heart. First, we find that we have only one star and one heart. Then they became two stars and two hearts. So our pattern is growing. Yeah, is growing, is getting larger, is getting larger. So, can you guess what should be the next elements? Yeah, star, 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 heart, heart, heart. Look here, we have one star, one heart, two stars, two hearts, three stars, three hearts. So this is the pattern we have, which is visual pattern. And don't forget, here we have a group repeated each time, which is called section, And this is section 1, star, heart. When our pattern is getting larger, the section number 2 became 2 stars, 2 hearts. And section number 3 became 3 stars, 3 hearts. Number 2, we have number pattern. From its name, it uses numbers that are arranged based on a rule. For example, we have here 5, 10, 15. What should be the next? We are here moving forward or moving backward? Yeah, we are moving forward. We are increasing. So each time I add 5. So it will be 5, 10, 15, 20, 25, 30. The third type is dot pattern. It uses dots that are built based on a rule. Here in the first dots in our pattern, we have here 2 dots in each column and 2 dots in each row. The next one, 3 dots in each column, 3 dots in each row. They became 4 dots in each column and 4 dots in each row. So our pattern here is getting larger also. Now let's practice on our math book. Lesson 1, the connect part is for applying. We have here red, we have some leaves: red, yellow, green, red, red, yellow, yellow, green, green. What should be the next section? Remember, we have the first section is green, red, yellow, green. The next section is red, red, yellow, yellow, green, green. What should be the third section? Red, 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 yellow, 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 green, green, green. Okay. Our number pattern 30, 40, 50, 60. Our rule is what here? What's our rule? We are increasing by 10. So our rule is plus 10. What should be the next? 30, 40, 50, 60, 70, 80, 90, 100, 110, 102. Let's apply together with dot pattern. In dot pattern here we use some dots. We have 3 images and we will notice what is happening. Our graph or our pattern is growing. In the first image we have one ball or one dot on the top and 3 dots on the bottom. So 1 and 3. In image 2 we have 1 dot on the top, then 3 dots, then 5 dots. So it became 1, 3, 5. The third image, 1, we are counting from the top. 1 dot on the top, then 3, then 5, then 7. So what is happening? Each time I add a below row with 2 dots increasing than the upper row. So image 4 will be 1, 3, 5, 7, 9. Yes, each time I will add a below row with the next odd number. Let's notice together or recognize our pattern. We have here all odd numbers in each row. All rows are odd numbers. 1, 3, 5, 7, 9. What should be the next? 1, 3, 5, 7, 9, 11. This is image 5. Now let's move to a challenging part. Challenging part. Record the number of counters in each image. How could you predict how many counters would be in the 10th image? We recognized that each time I add extra below row with 2 more dots than the upper row. And we noticed also that all the numbers of counters or dots in each row are odd numbers. If we started from the top, we will find that first figure has 1 plus 3. Second figure has 1 plus 3 plus 5. Third, 1 plus 3 plus 5 plus 7. Fourth, 1 plus 3 plus 5 plus 7 plus 9. Fifth, 1 plus 3 plus 5 plus 7 plus 9 plus 11. Each time I will add the next odd number. In the 5th image, all dots are equal 36. So number 6, it has 36 dots plus 13, which is the next odd number after 11. All of them equal 49. Then we will take 49 in 7th and add 15. And in 8th we will take 64 and add 17. In 9th we will take 81 and add 19. And the last figure, 10th one, it has 100 plus 21, which are 121 dots. Here our teacher is describing or explaining this problem to her students, and one of her students told her that it feels that this problem is very hard and The teacher said, "You may meet many problems, easy ones and hard ones. If it's hard, just think like a mathematician preserver. A mathematician preserver. Try a lot of different strategies and never stop trying and never give up." Preserving mean keep trying and never give up. And mathematician preserver, when solving a math problem, they try lots of strategies and never give up, so please be one of them. Now we will move to graph. We will discuss three types of graph: bar graph, pictograph, line plot. Let's start with bar graph. We studied it already in grade 2 and we said that it has two sides. Bar graph has two sides. This year we became older or we get bigger, so we will call them axes. Axes. So it has two axes, vertical axis and horizontal axis. And they should be labeled to understand the graph. Labeled means they should have a name. They should have a name. Scale. The number on one axis. The numbers on one axis, vertical axis or horizontal axis. We have numbers in one axis. These numbers may be in horizontal direction or in horizontal axis or in vertical axis. And from its name, bar graph uses what? Uses bars. Bars are columns which represent values of our collected data. Let's move to tally marks. Tally marks are groups of 5 lines, 4 vertical lines and 1 diagonal line. Like this. Yes. We use tally marks to collect our data and represent it in our graph. For example, let's collect data about siblings. Here we find a table for siblings. We have a column for number of siblings and number of students. 0 sibling. We have 6 students have 0 siblings, and for 1 sibling we have 8 students have 1 sibling, and in 2 siblings we have 3 students have 2 siblings, and 2 students have 3 siblings, and 3 students have 4 siblings, and 1 student have 5 siblings. Listen to, let's apply our sibling data to make our bar graph. First, we will write the title. Our title is about siblings of our students. And let's give a label for vertical axis, which is number of students. And in horizontal axis, we have number of siblings. 0 sibling, 1 sibling, 2 sibling, and so on. Let's apply our data. Yes, okay. Now let's move to our math journal. Write 2 questions that could be answered by looking the data at data in your sibling bar graph. Here, if we looked at this bar graph, can we answer this question? How many students have 0 siblings? We will go to 0 siblings column and move up, up, up till we reach the top. It's 6 students. Question number 2. Do all students have the same number of siblings? No, they are not the same. Lesson 3, we have a table here about favorite desserts. Favorite desserts. We have here basbousa and kunafa and sweet potato, sweet fatir, rice pudding, and Ali. Here we have our numbers represented by tally marks. Let's count together. In basbousa we have 4 and kunafa we have here. Once we find a group of 5, we will know that they are 5. We will not need to count. Just we find one diagonal, we will know that they are 5. So we have 5 here and 4 ones, so all of them are 9. And sweet potato 3, sweet fatir like this also. 2 groups of 5, so 5 plus 5, 10, and 2, they are 12. Rice pudding, they are a group of 5, so they are 5. Ali have 5 and 5, so all of them are 10. We will represent this table using pictograph. Let's remember together, pictograph uses pictures to show the data. And here we will have, our title is favorite desserts. And we will find the column on the left for desserts and the number of students in the next column. We will have our key that tells me that each one smiley face equal 2 students and each half equal 1 student. In basbousa we have 4 students. For how to represent 4 using our smiley faces, each one smiley face equal 2. So it means as we can count with skip counting by 2, we can represent our smiley faces. 4 will be 2 smiley faces. 2, 4. Let's move to our line plot. It's the third strategy using graph. It's a quick graph uses x's on a number line. From its name, line plot, so we use number line to show data. Here our number line, on this dashes we will write our numbers, and don't forget we can start at any number. We can start from 0, from 5, from 12, from 20. Never mind, you can start at any value. And don't forget to write the title on the top. The title which tells me what I am doing. I'm doing what? This graph is telling me what. And in the bottom, we will write the label which tells me these numbers refers to what, and the key which tells me x's are equal what. Here, if we put x on 13, it means the frequency of 13 is 1. And if we put 2 x's on 12, it means the frequency of 12 is 2. So, what is the frequency? Frequency is telling how many x's on this point. So, what is the frequency of 14? 0. We don't have any x's at 14. What is the frequency of 12? 2, because we have 2 x's at 12. And don't forget, as we said, the number line can start at any value. Here in lesson 4, let's apply in our math book. Create a line plot using beans in bag data. Be sure to give your number line or line plot a title and a key. Here we have bags, bags of beans, bags of beans. And we counted the beans inside the bags, and we found that we have 3 bags contains 20. Each one contains 20 beans, and we have 2 bags, each one contains 23 beans, and we have 2 bags, each one contains 27 beans. So what are we doing now? We are counting beans. So this is our title, and we will write our numbers. We can start at any point, at any number, so we can start from 20, no problem. 20, 21, 22, 23, and so on till 31. Let's start to put the label. Label, we said that it tells me these numbers is referring to what? The number of beans in our bag. 20, 21, 22, these numbers of what? Of beans in our bag. Let's start to put our X's. We found that 3 bags contains 20. So on 20, we will write 3 X's. And we found that 2 bags contains 23. So at 23, we will write 2. And 2 bags contains 27 beans, so we will write 2 X's at 27. So X equal what? Equal 1 bag. Each X is referring to 1 bag. 3 bags of 20, so 3 X's. 2 bags of 23, so 2 X's. So X equal 1 bag. Here we will find a challenge. If we dumped all the bags that had the most beans on the floor, how many beans would we have on the floor? If we made the most beans bag are empty, we drop down all the beans on the floor. All the beans? All bags? No, the most beans bag. The most, the greatest, or the highest value. What? 27. We have 2 bags contains 27. So we will drop down these 2 bags on the floor, and we will count all beans. So 27 plus 27 equal 54 beans. Our math journal. How are these types of graph are the same? We said that we have 3 types of graph. How are they the same? All of them are to show data and have a title. And how are these types are different? We will find that bar graph using bars, pictograph using pictures, line plot uses number line, and X's to show data. The last question, which do you prefer and why? It's for you, you can answer it. Let's move to measurements. We have 3 types to measure length. Meter, and its abbreviation is M. Centimeter, which is a little bit smaller than meter, and its abbreviation cm. Millimeter, and its abbreviation mm. What is the meaning of millimeter? We didn't study millimeter before. Here we find our pencil, our crayon, our eraser of the pencil. Our pencil here, its front end is 1 millimeter. 1 millimeter, and this crayon 2 millimeter and this eraser 5 millimeter. What are these millimeters? Here in our ruler we find some numbers 0, 1, 2. Between each number and the other one we will find 10 dashes. These 10 dashes, each one dash and the next one, between them this small distance is called millimeter. So these 10 dashes equal 10 millimeter. So 1 centimeter equal 1 millimeter, because between each two numbers 1 centimeter, and between each two numbers 10 dashes, which are 10 millimeter. So 1 centimeter equal 10 millimeter. And don't forget, we studied before, 1 meter equal 100 centimeter. You need to memorize it and don't forget. So if we want to convert between meter and centimeter, we want to convert meter to centimeter, we will put 2 zeros because 1 meter equal 100. So we will put 2 zeros from meter to centimeter and 1 zero from centimeter to millimeter, because 1 centimeter equal 10. This 10 contains only 1 zero. So between centimeter and millimeter we will put 0. In the opposite direction, between millimeter, if we want to convert millimeter to centimeter, it means from the smallest unit to the greatest unit, we will cancel 0. We will cancel 0. And between centimeter and meter, if we want to convert centimeter to meter, we cancel 2 zeros. 2 zeros, because 1 meter equal 100 centimeter. Now let's practice. We have some examples here. 2 meter equal what centimeter? First, look at the unit. We are converting what? Meter to centimeter. So meter equal what? Meter equal 100 centimeter. So 2 meters equal 200 centimeters. 7 meters, 700 centimeters. If we want to convert in the opposite direction, we have 500 centimeter and we want to convert to millimeter. From the smallest unit to the greatest unit, we will cancel 2 zeros. So it will be 5 millimeter. If we have 5 meter, and number 4, we have 4 centimeters equal what millimeter? We are converting from centimeter to millimeter. We know that 1 centimeter equal 10 millimeter. So 4 centimeter, 40 millimeter. 16 centimeter, we will put what? 1 zero. So it will be 160 millimeter. And in the opposite direction, if we have 230 millimeter and we want to convert them to centimeter, we will cancel 1 zero. So it will be 23 centimeter. Lesson 5. We have here an example of line plot. The length of a primary 3 student's hand from the wrist to the middle finger. Here we put numbers on our number line. These numbers refer to what? Length in hand in centimeter. In 10 we found 2 x's, and on 11 we found 3 x's. It means each one x equals student. So we find that two students, their length, their hand length equal 10. 3 students, their hand length equal 11. So if I asked you, what is the frequency of 15? Yes, we will look at 15 and count how many x's? 4 x's. So the frequency of 15 equal 4. Now let's apply to lesson 5. Measure the pieces of string and record their length in centimeter. We have some strings and we will measure their length in centimeter. The first one was 3 centimeter, then 9 centimeter, 11 centimeter, 5 and 7 centimeter. He is asking me to order the length in centimeter from the shortest to the longest. It means from the smallest number to the greatest number. So this is which order? Ascending order. So we will write 3, 5, 7, 9, 11. Our math journal. Where do you use measurement in the world outside of math class? We are using our measurements in what? We can use measurements in designing our home and in designing our clothes. Yeah, great. We can estimate length or measure exactly. So we have two ways to measure length. Maybe by estimation. By estimation, it means I can look at a pen and tell my friend that it's about 10 centimeters, but I didn't measure it. So I can use my eyes or my body benchmark. How? We can just look at item and guess its length, or body benchmark, as we learned before that our width of our pinky finger, it's nearest to 1 centimeter. And if we opened our arms, the space or the distance between our hands will be like 1 meter. This is estimation way. This is the estimation way. And the exact way to measure the length, we will use ruler or meter tape. Ruler or meter tape. Now let's apply. Our lesson 6 is applying four measurements. We have here some images and we will decide we can use meter or centimeter to measure it. Don't forget, meter is the unit used for long items and centimeter used for short items. We have some trees here. We will measure them using meter, sure. And some figs, we will use centimeters. And building, we will use meters. And our insect here, we will use centimeter. And our orange here, we will use centimeter. And the length of the horse will be in meter. Our challenging: name at least 3 or other objects that you could measure in centimeter and at least 3 other objects that could be measured in meter. What could be measured in centimeter? Maybe grapes, buttons, razors. could be measured in meter, pool, bed, sofa. Our math journal. When might it be okay to estimate a length? We don't have any problem to estimate a length. When? I can estimate if I am measuring a length of a building or a road to home. It's not a must to measure exactly. But when would you need to exact measurement? I need the exact measurement if I design clothes or my house. I need to be accurate. Lesson 7. We will name some objects and record the unit to measure. Pencil case, 15 centimeter. Button, 5 centimeter. Eraser, 5 centimeter. Sandwich, 15 centimeter. Pen, 10 centimeter. Ruler, 20 centimeter. Copybook, 25 centimeter. Shoes, 15 centimeter. So we will make here a line plot using this table, and its title will be length of objects we measured, and the label will be length in centimeter. We will start from 5, 10, 15, 20, 25, 30, 35, 40, 45. We don't have 40, we will stop at 35. Okay. How many items have 5 centimeter as a length? We have only 2, so we will write 2 x's on 5. How many items are 10 centimeter? Only 1, so we will put 1 x. How many items are 15 centimeter? We have 3 items, so we will write 3 x's. 20 centimeter, only 1 item. 25, only 1 item. Our math journal. Look at the line plot and think about the data shown on it. Write a statement you can make about the data. Here we will find that the frequency of 15 is 3 because we have 3 x's at 15. Lesson 8. Measure the pieces of string and record their length in millimeter. We before measured it, and it was the first one 3 centimeter, the next 9, and the next 11, 5, 7. How to convert from centimeter to millimeter? Don't forget we said that 1 centimeter equal 10 millimeter. So 3 centimeter will be 30 millimeter, 90 millimeter, 110 millimeter, 50 and 70. Each number we added 1 0 to it. We added 1 0 to it. Lesson 9. Let's apply. Use table below to record your data. Remember to record the unit of measurement. Here we have some objects and we will find its length in centimeter or millimeter. If we have a paper clip, it's 25 millimeter. Button, 10 millimeter. Eraser, 15 millimeter. Olive, 15 millimeter. Date, 20 millimeter. Lemon, 30 millimeter. Key, 45 millimeter. And the last one, pen, 25 millimeter. Lesson 10, we will take these values and we will create our line plot, and we will check if we answered all the questions. First, we will write the title. We are here measuring our object, so the measurements of our object, and we will write the right sign at I gave my line plot a title. Then we will write the label. Here we will put the numbers of the length of items. So the numbers on number line refer to length of our object in millimeters. So I will label my line and I wrote the unit. And I will put numbers. I will start from 10 and skip counting by 5, 10, 15, 20, 25, 30, 35, 40, 45, and I wrote the unit of measurement. And my work is neat and organized. The key tells me that x equal 1 object. So in 10, I will write how many x's? I have only one item, its length is 10, so I will write only 1x. 15, how many items have 15? How many items have 15? We have only 2 items, eraser and olive, so I will write 2 x's. 20, how many items? Their length are 20, only 1, so 1x. 25, only 1, or 2, no, 2 items, paper clip and pen, so I will put 2 x's, and so on. You can complete your line plot. Thank you for the watching. Hope you enjoyed.